get started with section 7.3. We're going to look at what we call the function catalog. This is where you have to be able to identify a function by equation and know what its name and know what its graph looks like. So our first function that we'll talk about is a constant function. This is where your y, which is your f of x, will equal a constant number. Notice there's no x on the right side, just a constant number, hence the name constant function. It is a horizontal line at that y coordinate. Next is your linear function. Now, some authors break your linear function into a more specific name called the identity function. So if I have y equals x or f of x equals x to the first power, that's the identity function, which means that your x and your y coordinates are identical. So please put up here right next to y equals x, this is the identity function, a very specific name, and that would be a graph like this red line, but it goes through the origin and it cuts quadrant 1 and quadrant 3 in half diagonally. That's the only way you can identify an identity function. A linear function is in that traditional y equals mx plus b form. You might recall this equation format where b is your y-intercept, m is your slope, and you can have a line that slopes uphill or downhill. We don't want it to be horizontal because then it's a constant function. We don't want it to be vertical because then it doesn't pass the vertical line test. So two types, very specific identity function, y equals x, y equals mx plus b, linear function. Next is your absolute value function. You have absolute value bars around the x term. In some way, shape, or form, you will see a v function. Now, if I want to just y equals this absolute value of x, then this corner of my v would be right here at the origin, cutting quadrant 1 in half diagonally and quadrant 2 in half diagonally. But if I start adding and subtracting values to the x to the inside or the outside, then my v shape moves around. And also keep in mind, the V does not necessarily have to open up. It can also open down if there's a negative being multiplied to the outside. A quadratic function, or otherwise known as the squaring function, so you might want to put squaring up here, just in case the author of the homework questions used squaring instead of quadratic. If it's just plain old x squared, then this bottom of the u is right here at the origin and it opens up. It can open down if there's a negative multiplied to the front of my x squared, then my u goes down. Polynomial functions, I'm going to be more specific and call it a cubic function. When you have x cubed, that's a specific name. A polynomial function is when you have x like to the 4th power plus 2x cubed minus 3x squared plus 5x minus 2. Then you're going to get a wavy line. But a cubic function really looks like your quadratic u, where they took the left side and flip it down. So half goes up, half goes down. Your reciprocal function, this is when you have 1 over x. Or it's a rational function. Also put reciprocal here. That's another name for this. All right, 1 over x. You cannot have x equals 0. That's why it's not touching the y-axis, because that's where x equals 0. And with 1 in the numerator, you can never have a y-coordinate value of 0. So this curve predominantly stays in quadrant 1 and quadrant 3. We can go 2 and 4, but then it has to be a negative being multiplied to it. Now, what I'm going to be concerned about is, again, you see a graph, you identify the function, the function's name or the function's equation. All right, so this is going to be a matching type of problem. I want to take a really close look at lines. Lines are very important, and I want you to understand that there's more to equations of lines than just y equals mx plus b. As I mentioned earlier, the slope is your m. You should remember rise over run. The b is your y-intercept, 0 comma b. So if I had, for example, in your notes, you have y equals negative 5 over 2 times x plus 6, my starting point is the y-intercept. Start at the origin, 1, 2, 3, 4, 5, 6. There's my starting point. Then my directions to more points is the slope. So my rise is a negative 5, so I'm going to go down. So if there's a negative in the front, put it on the top. Always keep your bottom number positive. So I count down 5. 1, 2, 3, 4, 5. And then run to the right. Run goes left and right. Rise goes up and down. So 1, 2 to the right, make a point. Do that again. 1, 2, 3, 4, 5. To the right, 2. You make as many points that fit on the graph. 1, 2, 3, 4. Doesn't fit. So now my line, arrow at this point, straight through that point, arrow here. Don't get cute and try to go past this point, because if you curve to the right or curve down, it's going to cost you a point. Now, there are two other forms for the equation of a line. This is slope-intercept. It has a small downside. It has to start on the y-axis. Why can't you start any point on the graph? Okay, that's called point-slope form. You are given a point and you're given a slope. This point can be anywhere on the graph. Now, this is y minus y1 equals m times the binomial x minus x sub 1. The x sub 1 and y sub 1 are your starting point. Notice there is a change in signs. All right, so I like to say find the x, change the sign. Okay, positive x sub 1. Find the y, change the sign of this number, positive y sub 1, and that's your starting point. M is still your slope. So if this equation is y minus 4 equals 1/3 x plus 3, find your starting point. Find the x, change the sign, negative 3. Find the y, change the sign, positive 4. That's where I'm starting. So 1, 2, 3, 1, 2, 3, 4 up. There's my starting point. My slope is 1/3, so that's telling me to go up 1, right 3. Up 1, right 3. Up 1, right 3. And again, I'm going to fill this in until I run out of graph. Now, bear in mind, I can also go in the other direction. Down 1, left 3. We can do that in reverse. Left 3, down 1, or down 1, left 3, however you want to say it. But some people like the staircase look of your lines, so fine. Draw your line, point to end point, put arrows there, and we call it done. Okay, the next form of the equation is called standard form. You're going to notice in this format we use all capital letters. And notice that x and y are on the same side of the equation, whereas before, x's and y were on opposite sides. We'll just take y equals mx plus b, just take it as faith. So capital A, capital B, and capital C are all integers. There's never a fraction in here. And traditionally, we like to have the A positive. It doesn't have to be. Some authors will tweak it, but traditionally we like to have that A be positive. Now within this equation, your slope, you got to do a little work. Your slope is going to be the opposite of A over B. Now why is that? Think about turning this into y equals mx plus b. You would subtract over the ax term, so negative ax plus c, then you divide by capital B, and there's your slope. All right, now, if you were asked to graph 2x minus 3y equals 18, this form of the equation is very popular in finding not only the y-intercept, but also the x-intercept, the horizontal intercept or the vertical intercept. So keep that in mind, because they will say horizontal and vertical for x and y intercepts. Okay, now why do I say this is very easy to find 2 points? And the nice thing is to draw a line, you only need 2 points. So here, think about finding the y-intercept. If you're looking for the y-intercept, the x-coordinate is automatically 0. So if you were to put 0 into that x, this term zeroes out. And you have negative 3y equals 16. And now we could technically say, all right, I'm looking for the y-intercept. I call it the cover-up technique. Cover up the x, solve for y. Oh, 18 divided by negative 3, negative 6. There's my y-intercept, 0, negative 6. 1, 2, 3, 4, 5, 6. I can plot that point. Well, I can do the same thing and look for the x-intercept. Put a y as 0. Every x-intercept, the y-coordinate is 0. So if we put 0 in the equation, think about covering that up. 2x equals 18, x equals 9. 1, 2, 3, 4, 5, 6, 7, 8. Oops, 9 doesn't fit on the graph. That's okay. Don't panic. Remember, you still have your slope here. So if I took opposite of A, negative 2, over B, negative 3, I get 2/3. So I can go up 2, right 3, plot a point. Up 2, right 3, plot a point. Or down 2, left 3, plot that point. There's my line. So you can either start at the x-intercept, start at the y-intercept, use the slope, or find the x-intercept and the y-intercept and then just draw a line between those 2 points. But even if you get the x-intercept and the y-intercept, you can always use the slope to plot more points, so it's easier for you to graph a line. Now, one thing that you're going to notice that when you're in more and you have to make a graph, you will click a line icon, you will click a starting point and an ending point, and then the line automatically appears because the program only needs 2 points to form a line. So that's why it's important to still know this form of the equation. All right, if you were asked to graph x equals 6, notice there's no y in the equation. Since there's no y variable in the equation, your line cannot cross the y-axis. So it has to run parallel to the y-axis. So I would go out to 1, 2, 3, 4, 5, 6 on the x-axis and draw a vertical line. Now keep in mind, if x equals 0, you're graphing the y-axis. I can put my line over it, but it didn't cross it. So keep that in mind. All right? The slope of a vertical line is undefined because you have all kinds of rise, but you have no run. So 0 is in the denominator. It's an undefined slope. Remember that. All right, the next equation is y equals negative 4. No x in the equation, so therefore you can't cross the x-axis. So we'll go down to 1, 2, 3, negative 4, and now run parallel to the x-axis. Now for a slope, I have no rise, but all kinds of run. So 0 divided by any positive or negative number is 0. So horizontal lines have a slope of 0. And if you forget, oh, which one was 0, which one's undefined, notice horizontal is spelled with zeros in it. Vertical has no zeros in it. All right, let's graph 3x plus 5y equals negative 9. Okay, so what do I see right away is that 3 can go into negative 9 right away. 5 doesn't, but that's okay. I don't need it. So I'm going to go find the x-intercept. I cover up the y. 3x equals negative 9. X is going to equal negative 3. Graph a point at negative 3. Now, because I don't want to attempt to find the y-intercept, which would be at negative 9/5, I don't want to break these into 5 equal parts and count down to negative 9. What we're going to do is find the slope. Remember, negative a over b. Negative 3 over 5. There's my slope. Go down 3 and to the right 5, plot a point. Down 3, right 5, plot a point. Or in reverse, up 3, left 5, plot a point. Draw your line and you're done. Okay, next, you have to be able to write the equation of a line when given 2 points or any other piece of information. Now, we just discovered that we have 3 different forms of the equation of a line that we can use. All right, so I'm going to do all 3 forms. In all 3 forms, you need the slope, and you're going to need a point. Okay, so since we need the slope, we need to use the slope formula. Second y-coordinate minus first y-coordinate over second x-coordinate minus first x-coordinate. Remember, the rise goes up and down. That's the change in your y's over your run, your change in your x's. So second y-coordinate minus first y-coordinate, negative 1 minus 8 over 5 minus 3. Negative 9 over 2. There's my slope. Now, which of these forms would be the best to use for this problem? Well, they're all good, but you're going to notice it really depends on what information you're working with. Okay, so that's why I'm going to do all 3 and let you decide, or we'll decide together, what's the best to use based on the information you're given. Remember, in my class, knowledge is power. The more you know, the more powerful you are. All right, so let's look at slope-intercept, because this is what you folks have probably used a lot. So y equals mx plus b, and I already found the slope, so I'm going to put negative 9/2 in for m. And I would venture a guess you would take a point. Well, for all my examples, I'm going to use 3, 8, and that way we'll base which one's the best, and we use the same point, so we can't say the points made the difference. Now, you probably put the 3 in for x and the 8 in for y, and then you tried to solve for b. Okay, downside to this is that this 2 does not divide evenly into the 3. Even if I use the other point, 2 doesn't divide into 5. So I am forced to work with fractions. This is why when you were in junior high or you were in high school, they only talked about this equation to force you to keep working with fractions so that skill wouldn't die. Well, you hate working with fractions, so what happens? You hated working with math. We'll fix that today. So negative 9 times 3 gives me negative 27 over 2. And then I would add the 27 over to the 8 to solve for b, which means, okay, I need to have common denominators, so this becomes 16 over 2. Or you go to your calculator and you go 8 plus 27 divided by 2, return my answer as a fraction, 43 over 2. If you use the fraction command, the alpha y equals, it should give you your answer back as a fraction. So there's my b value. There's my equation. You're forced to work with fractions. All right, next form, point slope. All right, so in point slope, we'll use the same slope, negative 9/2. We'll use the same point. 8 is going to be y1. 3 is going to be x of 1. Oh, guess what? You're done. You tell me right now which form of the equation is the easiest to write the equation of a line given 2 points. That's right. It is point slope form. You can't get any easier than that. Now, if I put in the other point, it's still correct. If you simplify both of them, you'll get down to this equation right here. All right, standard form, that's next. AX plus BY equals C. Well, my slope is -9/2. Now remember, the slope in standard form is -A/B. Okay, so I'm not going to make this too difficult, but what do you think the B is? Oh, yep, you're right, it's 2. And what do you think the A is? Yep, you're right, it's a 9. So I need A, B, and C. You already have 2 out of the 3 variables. Now, I need to find C. Okay, you need to use your point, 3, 8. Put the 3 in for X, the 8 in for Y. 27 plus 16 equals C. That means 27 plus 16 is 43. Look, Mom, no fractions. So put this 43 up here into that C. 9x plus 2y is equal to 43. So I hate to tell you guys this, but the one form of the equation that they always wanted to use in high school is actually the least efficient. These two forms, this is the easiest, second easiest, never a fraction to be found. Here, there's always fractions. Sorry, I apologize. All right, now, let's talk here real quick. When would y equals mx plus b be really good to use? Well, since my slope was -9/2 and 2 is in the denominator, if my x happened to be an even number where this denominator can divide into your x coordinate, then you're not going to have fractions. And then y equals mx plus b is good to use. Okay, that happens maybe 1 out of 10 times. Can we agree? Again, 2 points, by far the easiest. Second easiest. And I'm going to be perfectly honest with you, on the test, you will get this question and you will have to find the equation of all 3 forms. Now, I'm going to give you a hint. I'm going to do this one first. I'm never going to multiply in this fraction unless this 2 goes into that x coordinate. If it doesn't, leave it alone. I'm going to do standard form next. No fractions. Okay, now, there's a number of steps over here. Work with me on this one. Go to standard form. Go to this equation. In 2 steps, you can have this. Subtract over the 9x and divide everybody by 2, and you have this form of the equation. I never do this. If I want an equation of a line and I can't get my slope's denominator to cancel into an x-coordinate, I'm over here. And if the directions tell me I have to have it in slope-intercept form, I go to standard form first and then I solve that for y. Minus 9x, divide them all by 2, there's your answer. Never do you work with fractions. You just end up with fractions on the last step. Okay, next, write the equation of a line that is parallel to the equation 4x plus 7y equals 11 and contains the point -2, 3. Well, which equation should we use? I hate to tell you this, but since they gave us standard form, you might as well stay in standard form. Here's my logic. What do you know about parallel lines? And that is they never cross each other, so therefore the slopes have to be the same. Now work with me for a second. The slope comes from the 4x and the 7y. -a over b. So if this is going to be the same slope, you just have to find a different c. So keep the 4x, keep the plus 7y, and set it equal to a new c, and go grab this point and plug the -2 in for x, the 3 in for the y. -8 plus 21 is 13. There's your new equation. That's it, folks. Now, if they say, okay, I want the equation of y equals mx plus b, subtract over the 4x, divide everybody by 7. You're done. Knowledge is power. The more you know, the more power you have. All right, like I said, in your homework, they'll probably want you to write it y equals mx plus b. So like I said, subtract over the 4x, divide everybody by 7, you're done. All right, write the equation of a line that's now perpendicular. 4x plus 7y equals 11 and contains the point negative 2, 3. All I did is change parallel to perpendicular. What do we know about perpendicular lines? Okay, perpendicular lines form 90-degree angles. That means their slopes are going to be opposite and reciprocals. So this equation for the slope is negative 4 over 7. It goes downhill. Well, if it's going to be perpendicular, then it's got to go uphill, which makes it positive. Opposites. To form the 90-degree angle, that's the reciprocal. So here's my slope, a perpendicular slope, positive 7 over 4. Watch what happens. My A is now 7, and my B is now 4, but notice opposite signs. Are you kidding me? Why wasn't I ever taught this in high school? I wanted you to work with fractions. So take the original standard form, flip the A and the B, and change the sign, and plug in your point to find the new C. If you want to see it work, there it is. Negative 7 over negative 4, that's a positive 7 force. There it is. All right, so 7 times negative 2 minus 4 times 3, negative 14 minus 12, negative 26. There's my new equation. And like I said, if they want it in y equals mx plus b, subtract over the 7x, divide everybody by negative 4, y equals 7 fourths x plus 26 over 4. You get the fractions on the very last step. Or if they put it as f of x or y, same thing. Okay, word problems. Now, most word problems are going to be function type problems. So you're going to want y equals mx plus b here. And I said, write a cost function that immediately made me think of y is your f of x, or in this case, c of m equals mx plus b. So let's talk about our y equals mx plus b here. M is your slope, or otherwise known as your rate. Your b is your y-intercept, or otherwise, in word problems, your starting point or initial value. Okay, so slope is the same as rate. Y-intercept is the same as starting point or initial value. Now, I'm bringing this all up front first before I even read the problem. Now I know what I'm looking for. So the yellow taxi cab company charges a $10 pickup fee. All right, is that a rate or initial cost? That's an initial cost. That's my y-intercept right there. That's the B. And charges a $1.25 for each mile. For each or per, that's a rate. That's my slope. So if I was writing y equals mx plus b, it would be y equals 1.25x plus 10. But they wanted y equals c of m. So this y becomes c of m, and then that means my variable x has to change to an m. And there's my cost function per mile. So when you see c of m, this is the cost based on your miles. No matter what they give you for variables. This can be any variables, but usually they're going to have meaning and use their initials. Okay? So when they want word problems with functions, think y equals mx plus b, but then you're going to have to change your y and your x out to the letters given in the function notation. All right, next word problem. I love this problem because students panic, they quit, they see so much verbiage here, they don't know where to start, they want to quit. I'm here to tell you this problem is as easy as writing the equation with 2 points where we did all three forms. That's how easy this is going to be. Here's the proof. In the year 2000, the life expectancy of females was 83.5. That's a point. In 2004, it was 86.5. There's another point. Write a linear function e of t, okay, linear function, so we're going to have to get y equals mx plus b involved, where t is the number of years after 2000. Okay, so we got to change our years based on how many years have gone past 2000, and E of t is the life expectancy in t years. Okay, then they want to answer some other questions here, but let's find our equation first. So, point time. In the year 2000, we were 83.5. Well, how many years are after the year 2000 is 0. And in 2004, that's 4 years after. So these are our t values. So this is like the x and this is the y. X and y. It's just going to be t and e of t. All right, I don't care with the notation now. I'm just thinking points. There we go, 0, 83.5 and 4, 86.5. Wait a minute, time out. Do you see something really nice and special here? Talk to me about those points. One of them is a good point, right here. Folks, that's your y-intercept. Anytime you get a 0 for the independent variable, your x, or in this case t, that's my y-intercept. Now I really want y equals mx plus b because all I have to do is find the slope between these 2 points. So time to use the slope formula. Second y, 86.5 minus first y, 83.5. That's a 3. 4 minus 0 is 4. There's my slope. So in y equals mx plus b, here's my equation. Y equals 3/4 x plus 83.5. However, you're going to see probably in the work e of t equals text box. So if this was e of t and you put an x here, they want a t. So e of t equals 3/4 t plus 83.5. This is my linear function. Now, then they asked us to estimate the life expectancy in the year 2009. Okay, wait a minute. 2009 would be how many years after 2000? That would be 9. So t equals 9. Plug in 9 into our t's. So e of 9 equals 3/4 times 9 plus 83.5. Well, guess who's going to do the work for that? Your calculator. 90.25. Second thing they asked us is estimate when the life expectancy will be 94. Okay, so 94 is the e of t. So now 94 is equal to 3/4 t plus 83.5. And now solve for t. Okay, subtract over 83.5. Calculator told me 10.5. How do I divide by 3/4? Well, technically I don't divide by 3/4. I'm going to multiply by its root. It's reciprocal. Somehow my fractions moved here. They need to be bumped up. So 3/4 times 4/3 cancels out. 4/3 times 10.5. T is equal to 14. So T is 14. That would be the year 2014. See, I told you it wasn't going to be that tough. Next example. In the year 2003, a certain college had 3,450 students. In the year 2008, the college had 4,100 students. Hey, this kind of looks like the previous problem. Write a linear function p of t. Okay, t is the number of years after 2000. Oh, wait a minute. We have 203 and we're after 2000. Okay, so again, these are our points. T is going to be our years, P of T is going to be our population. So let's write our equation again. Make your points. Year 2003 means T is 3, and the population was 3,450, 2008. T is 8, 4,100. There's my 2 points. What's difficult here? No y-intercept is given. Okay, so we might have to do a little extra work. But what we can do right away is find the slope. So finding the slope, 4,100 minus 3,450 is 650. 8 minus 3 is 5. Oh, this is a good slope because I can simplify my fraction to be 130. Yes, we will work with y equals mx plus b. So I'm going to put 130 in for my slope. I'll change these out later. Then I'm going to pick a number to plug in. Oh, it doesn't matter. I'm going to choose 8 and 4,100 only because it ends in zeros here. 4,100 equals 130 times 8 plus b. Multiply that out, 1,040. Let's subtract it over. 3,060 is my b. There's my y equals mx plus b equation. But for the homework, we probably have to enter it as p of t equals 130t plus 3,060. Okay, there's the equation. Now, if I would have had an ugly fraction slope, then I would use the point slope formula to write my equation. Or if we want to go to standard form, we could go then to, use standard form if we have to have it in y equals mx plus b. All right, so estimate the population in 2012. Okay, 2012, t would be 12. Plug in a 12. 130 times 12 plus 3,060. Calculator tells me 4,620. That one's done. Estimate the year when the population will reach 5,400. Okay, that's P of T. 5,400 equals 130t plus 3,060. Subtract over the 3,060. That's 2,340. Divide by 130. T is 18. That will be the year 2018. See, writing equations aren't that difficult if you know what you need to find. If you're talking parallel and perpendicular, probably are going to work in standard form or whatever they give you. If they give us stuff in slope intercept, yeah, then we'll probably work with that. If they give us in standard form, let's work with that. If they give us points and all this verbiage, find your points, go from there. Okay, and that wraps up our 7.3.